So it's not too much of a jump. Just remember that if it's not in equilibrium, you don't call it the K, you call it the Q. Okay, so if you have a equilibrium constant where the concentrations aren't at equilibrium, just call it Q, and that's the reaction quotient. So it is actually quite useful for Q. So as you saw in the other extra in the previous video, you can use it for KSP to determine if a salt will dissolve or not, to be far more specific than the approach that your data book takes. And also you can also determine whether the reaction is going to go to the left or right. And so if Q is greater than K, so you just need to know its products over reactants. So if Q is greater than K, that means the products are too large. And so the reverse is happening. So the products are turning into reactants in order to get to the equilibrium. So if Q equals K, well, nothing needs to be said there. It's in equilibrium. And so if Q is less than K, so products over reactants, so if Q is less than K, that means this one is larger than it should be, or this one is smaller than it should be. And so reactants must be turning into products. So the forward reaction is going on. Okay, so don't memorize any of this stuff. Just be able to work it out. If you memorize it, you might forget. Or you might get it wrong, or you might be thrown in with sort of a complex question that requires you to understand it. So please try and avoid memorizing anything. And so this is just a repeat of the previous video, the same question, but this time you'll know what Q is exactly. Where's my pen? And so this is the question. It tells you it's not at equilibrium, so what's going to happen? And so you put the numbers in, it's 4. And so products over reactants, 4 is larger than 1. And so this means this is too large. And so the products are turning back into reactants. And so the reaction is going into the left.